Okay, so today we're going to be talking about the classification of matter and kind of an introduction to chemistry. So, chemistry is the science that seeks to understand the behavior of matter by studying the properties of atoms and molecules. So, I'm going to write something real quick. So we have atoms, and we have molecules. Okay, so I'm going to reread this. Chemistry is the science that seeks to understand the behavior of matter by studying the properties of atoms and molecules. So an atom is the fundamental building block of matter. And a molecule is simply two or more atoms together. And that would mean that they are chemically bonded. Okay, so I'm gonna do a little chart real quick to kind of split up matter so you can kind of get a clear picture of what exactly we're going to be dealing with in chemistry. So you can feel free to copy this or make your own. I didn't make that arrow long enough. Alright, there we go. So we have, I'm going to do them in two different colors to kind of split them up. So we have pure substances, elements, and compounds. And over here, I'm going to do, we have mixtures, and then that would be homogeneous and heterogeneous. Okay, so a pure substance we're going to talk about the stuff on top, but pure substances is only one component. So, example would be an element. So, elements are substances that cannot be broken into simpler substances. Cannot be broken into simpler substances. guess I probably should have done that in blue, but whatever. Okay, so example of this. Here, let me close this. So an example of this would be hydrogen. It's an element. It's the first one on the periodic table. So we have okay, another one would be carbon. And just for simple, we'll do one more. Oxygen. Sorry, my drawings are pretty horrible, but okay, so when you look at the periodic table, we have elements. So these are all examples of elements right here. Every single thing that is on the periodic table is an element. That means that it is a pure substance. It also means that it cannot be broken into a simpler substance. Now, you're probably thinking, oh wait, I've heard about protons and electrons and all that stuff. Yes, those are components of it, but we're not talking about that. We're talking about like breaking it into something different. At the end of the day, those would still be part of that element. So anyways, we're going to go over compounds real quick, because those are when we start getting into other things. So a compound is a substance. So it's a substance that is composed of more than one type of atom. Alright, so I ran out of room. Anyways, I'll just copy this and we'll go to the next page. So alright, now you have time to copy it. Alright, so for instance, we're going to pretend these are atoms. We'll have a red one, a blue one, black one, and a white one. So these are all different atoms, right? So I'm going to show you what I mean with a compound. So anyways, say we had, I'm going to say this is oxygen, carbon, hydrogen, nitrogen. These are usually, things that are represented when you use model kits or whatever online if you see 3D models. So say I wanted a compound of CO2. So I would have one of these, and I would have two of these. So this would be carbon dioxide. Say I wanted H2O. We would have one of these, and you're starting to see how a compound is more than one type of atom joined together. Now there are instances when you can have the same element joined together on the periodic table. I get into it a little more, but I'll give you a short example. There's 7 of them that found in nature in the universe are bonded together. These are called diatomic molecules. So So a diatomic molecule would simply have two elements joined together. So an example of that would be like you have H2, O2. I'm not going to go over all of them, but I'll just show you. So O, O, and then we have our lines in between. Or we have H and H. So O2, H2. So that would be like a example of when you would have two of the same elements joined together. There are circumstances when that happens. It's not just diatomic molecules, but freely found, this is how you're going to find all of these. All right, so I'm going to go over compounds can be pure substances. They are pure substances. So because a pure substance means that you have one thing. So if I were to give you a glass and it had water in it, so I'm going to just write in H2O, and that was the only thing in there. That means that you have a pure substance, because all you have in that glass is water. So this is important for when we talk about mixtures, because mixtures are not pure substances, but there's different classifications of mixtures. So this is all H2O. It's a pure substance. All right, so let me all right, perfect. So we have mixtures. So a mixture is more than one component. Think of when, you're making cookies or something like that. You mix a bunch of stuff together and you have something else. But not all mixtures are equal. There's two different types. So a mixture can be separated without altering the chemical composition. That's the important thing. A mixture can be separated without altering the chemical composition. So, for instance, I'm going to show you the two different types. I'm going to draw out an example, and then I will label it right next to it. So I'm going to do this one first. I'm sure you did this as a kid. So like if you put water and oil in the same jar or same glass, the oil's gonna separate because it doesn't mix because of the chemical composition of it, but also it's gonna be less dense due to its density. So it will float essentially on top of the water and it won't mix. No matter what you do to it, you can shake it, you can turn it upside down, it's always going to find its way to the top because it's less dense. And it's not going to mix due to other factors that you'll understand later in chemistry. So, as opposed to if you had, like if you like seltzer water or sparkling water, all that is it's water with CO2 in it. Makes it into carbonic acid. So let's say we had CO2 and water in there. You're not going to be able to tell the difference. It's still clear. It still looks like water. It looks like one thing. So this is the biggest difference that I can kind of relay in terms of this concept is all mixtures aren't created equal because right here, if it looks like one thing, it's a homogeneous mixture. And over here, because it looks like two things, it's a heterogeneous mixture. Sorry, I'm not the best at spelling. Alright. So, I'm going to write the definitions on the next page. So, if you need a second to copy this, you want to take a picture, just pause the video. So, homogeneous. The meaning is multiple substances, but it appears to be only one. And then the last definition would be heterogeneous. Heterogeneous just means the composition varies from region to region. So, alright, so these mixtures are clearly different. If you remember, homogeneous was, say you had like water and CO2. That's one thing. It looks like one thing. When you have coffee would be a homogeneous mixture because it looks like one thing. It just looks like coffee. Where you start to have differences is when you can clearly see there's two things mixed together, where you have two different regions like oil and water, or like a solid and a liquid all in the same and you can see them. That would be a heterogeneous mixture. And that's pretty much it for this video.